Hi everybody, my name is Andrew Plasik with Universal EE-PAC. I'm the Director of Sales here, and today I want to talk to you about some systems that are going to an installation in St. Petersburg, Florida. These systems are going to service an aeration basin. There's 3 blowers, 2 duty, 1 standby, 2 aeration basins. The standby blower can service either. The city already has existing aeration equipment. They're replacing the existing equipment with this new high-efficiency hybrid tri-lobe double EE-PAC. So what's interesting about these blowers is that they're going outdoors. They are going outdoors in a tropical environment. So what you have is fully enclosed. This is called our NEWRP acoustical enclosure. And this one's customized a bit in that it's 1/8 inch aluminum. It sits on a sub-base. The blower is mounted to the sub-base with vibration isolators. That means that there's no special foundation required. When this is in operation, this is going to have a noise level below 75 dBA, and that's at the peak design flow. It's going to be much lower after it's in operation at a low flow. What you can see here is a 200 horsepower induction motor directly coupled to a hybrid tri-lobe compressor. So the direct coupling eliminates belt power transfer losses. So this machine is going to be 5% more efficient than any other belt-driven or gearbox-driven compressor. You see that there's all kinds of wiring. There's going to be bearing vibration transmitters, bearing temperature transmitters for both the motor and the compressor. There's temperature transmitters, pressure transmitters, vacuum transmitters on this machine, and everything feeds back into this complex control system that we'll talk more about. We are supplying these blowers with extensive controls. The customer not only wanted to upgrade the plant capacity, blower type, and telemetry, they wanted to get the most possible energy savings out of current blower technology by adding multiple DO probes, nitrogen probes, and airflow meters so that they could automatically adjust airflow to each basin and monitor demand within zones of each basin. This would ensure they would only use the air required, and the blowers would adjust their duty points accordingly. To accomplish this, we provided a master control panel, VFDs, and a local control panel for each blower. This equipment will be located outdoors, so we placed the VFDs and master control panel in a large climate-controlled electrical enclosure that installs next to the blower pad. The blowers are located under a canopy, but still very much exposed to the elements, so each local control panel is housed in an EMA4X stainless steel enclosure that opens to provide access to an Allen Bradley, HMI, PLC, vibration monitoring system, temperature monitoring system, local blower process monitoring, and climate controls. The local blower protection, alarm, and instrumentation telemetry is consolidated and communicated independently with the VFD, master control panel, and plant control room via managed Ethernet switches. This ensures the equipment and process can be controlled and monitored from multiple locations. The new double EE-PAC blowers, along with other upgrades, will satisfy twice the existing airflow demand while providing for exacting control of air delivered and power consumed. The double EE-PAC blowers were selected because they operate more efficiently and provide far greater turndown and precision of control than other blower technologies.